Hello everyone. Now I will discuss about the milestone project. In the first session, we have done the half adder. This is the half adder of the schematic, and this half adder consists of two input, which is A and B. This two input is going to do the addition and come up with two output, which is the sum and the carry. Now if we run the waveform file, we run the simulation. Okay, the output of the half adder is like this. If we compare to the truth table of the half adder, which is exactly the true, if we can check if A and B is 0, the sum and the carry is 0. So sum and the carry is 0. Next, if A is 0, B is 1, A is 0, B is 1, the carry is 0, the sum is 1. The carry is 0, sum is 1. Same as the follow, is exactly follow the truth table. The full adder. This full adder consists of the combination of two half adder. This one is retrieved from the first section, which is the half adder. This full adder consists of three input, A, B, and C. C is as a carry, and the output is the carry and the sum. If you run the waveform file, we run a functional simulation. The output is also true if we compare the output with the truth table. If we pick this one, A and B, A is 0, B is 1, the carry is 1. A is 0, B is 1, carry is 1. This column. The output is of carry is 1 and the sum is 0. The carry is 1 and the sum is 0, which is exactly the truth. We do have checked the following output. It is exactly the truth as the truth table. In the third section, we have done about the ripple adder. This is the schematic of the ripple adder. This ripple adder consists of multiple input of number A and number B. The number A is 4-bit, which is consists of A0 until A3, and B is also the same 4-bit number, which is from B0 to B3, and the output is also the output is the sum of two number, which is also 4-bit, and the carry and the input. This one is the input. Sorry. If we run the program, in the project we have to predict the output of the carry and the sum. So we just do it as a simple mathematical algebra, 0 plus 0 is just 0 for these two, and f is actually number of 15 in decimal. So if we run the program, okay, this is the output. If we check one by one, the output is follow the logic of the simple mathematical algebra.
This one is my design for the 2-to-1 multiplexer. This one is the schematic with two input A and B. S is represent the select bit and Y is the output bit. So I have compiled it, open the simulation. So I have insert the waveform and I have done running the simulation. The output is like this. When S is 0, it will take bit A. So the output will be 0. When S equals 0, A equals to 1, the Y will become 1. And when S is equals to 1, A is equals to 0. So the Y will be 0. So this is the function of a 2-to-1 multiplexer. So this one is the 4-bit 2-to-1 multiplexer. The input A and B has a 4-bit and S is a select bit, while the output is 4-bit. This symbol is created from the previous project called 2-to-1 multiplexer. I've already compiled it. So this one is the inserted value for the stimulation. I have inserted it, I have already stimulated it. So this one is the output of the stimulation. Let's compare it with the truth table. So when A is equals to F, 0, when B is equals to 0, S equals to 0. So S equals to 0, so it will select the A bit, so the output will be F. When the S is equals to 0, so it will select the A bit, A is equal to 0, so the output will be 0. When S equals to 1, it will select the B bit, so the output will be 5. Same things to here, output is A. So when S equals to 0, it will select the A bit, so the output is 8. When S equals to 1, it will select B bit, so Y, the output will become A. So compare the output with the result of the simulation. So the first one, F0, 5A, 8A. So it is the same with the simulation.
So open the quadrants, open up the project file, ready cell. Okay, so this is the schematic diagram. So after you done the schematic diagram, you can start compiling. So this is the process. So after finish, this is the report. After that, we can enter our, open out our waveform. So this is the waveform given, similar to this. And then start the stimulation over here, and then waiting for the result. So this is the result. So for 1.3.2, we open up another new project. Open the project. Where is the 4-bit open? And then open up. This is the schematic diagram. Okay. And then start the compilation. So done. This is the report for 1.3.2 diagram. After that, we open up our waveform. This is the waveform given in the PDF file. This. So after that, we start the stimulation and then waiting for the result. So this is the result for the register 4-bit. So after done this, we convert the module into the symbol file, which is read 4-bit BSF, which you can convert over here. This will become the symbol file. So that's all.